talk about some major examples of earthquakes. This picture shows damages of the 1976 Tangshan earthquake. On July 28, 1976, at 3:42 local time, a quake of magnitude 8.2 on the Richter scale struck Tangshan, China. Ground shaking lasted 23 seconds and was followed by a 7.8 magnitude aftershock some 16 hours later. The epicenter of the quake was near an industrial city with about 1 million inhabitants. The number of deaths was around 750,000. It is considered to be the largest quake of the 20th century in terms of death toll. This picture shows some of the damages from the 1985 Mexico City earthquakes. On September 19, 1985, at 7:19 local time, a quake of magnitude 7 on the Richter scale struck Mexico City, Mexico. Ground shaking lasted more than 5 minutes along the coast, and parts of Mexico City shook for 3 minutes. This is exceptionally long. The typical earthquake lasts on average less than 60 seconds. The complete seismic event included 4 quakes, a foreshock of magnitude 5.2 on May 28, 1985, the main shock on September 19th, and 2 aftershocks, one on September 20th, 1985, of magnitude 7.5, and the second on April 30th, 1986, of magnitude 7. The epicenters were located off the Mexican Pacific coast, more than 350 kilometers away. But due to the strength of the quake and the fact that Mexico City sits on an old lake bed, it suffered major damage, and about 10,000 people died. This picture shows an effect of the 2010 Haiti earthquake. On January 12, 2010, at 4:53 local time, a quake of magnitude 7 on the Richter scale struck Haiti. Ground shaking lasted 90 seconds and was followed by a 6.0 aftershock that occurred at about 11:40 local time on March 11, 2010. The epicenter was located near the town of Langao, about 25 kilometers west of Port-au-Prince, which is Haiti's capital. About 160,000 people died. Here's a picture of the damages from the 2010 Chile earthquake. The epicenter was located off the coast of the Maule region of Chile. It was strongly felt in 6 Chilean regions, including Santiago. The death toll was about 600. The time and date was 3:53 local time on February 27, 2010. It was a magnitude 8.8 and lasted for 90 seconds. A 7.4 aftershock occurred at about 11:40 local time on March 11, 2010. Almost every year, a large earthquake occurs somewhere in the world and captures the public's attention. Meanwhile, every day, thousands of smaller tremors often go unnoticed by most people. Although we usually consider the ground to be solid and stable, the earth is in fact constantly shifting under our feet. Here are earthquakes across the span of 6 days in New York. They are very small and you cannot feel them. However, highly sensitive sensors will capture them. Seismic recording stations record every ground shaking, including non-seismic related events, such as nuclear explosions and sinking of submarines or large oil derricks. The sinking of submarines and large oil derricks can produce 3.5 magnitude quakes when they hit the ocean floor. This figure shows a comparison of signatures of nuclear test explosions and an earthquake in 1998. Notice how different the signatures of nuclear test explosions are from the signature of an earthquake. In summary, seismic recording stations record every ground shaking, including non-seismic related events. So geophysicists can use seismograms to substantiate or dispel reported events that could produce significant ground vibrations. Let's conclude this lecture on earthquakes by discussing tsunamis, which are very important effects of earthquakes. What is a tsunami? Tsunamis are long wavelength, long period sea waves produced by the sudden or abrupt movement of large volumes of water. Large waves produced by an earthquake, a submarine landslide, an underwater explosion, or a meteorite impact can overrun nearby coastal areas in a matter of minutes. Not all earthquakes produce tsunamis. Actually, thrust fault, also known as reverse fault, and normal fault earthquakes can cause large tsunamis because these earthquakes can uplift or downdrop the seafloor. Tsunamis have an extremely long wavelength, up to several hundred kilometers long. The period is also very long, about an hour in deep water. In the deep sea, a tsunami's height can be only about 1 meter tall. It is not felt aboard a ship or seen from air in open ocean, but can be measured by buoy or satellite altimeters. Tsunamis are often barely visible when they are in the deep sea. This makes tsunami detection in the deep sea very difficult. Tsunami advance across the ocean at amazing speeds, between 500 to 950 kilometers per hour. The deeper the water is, the higher the speed is. Approximately, the tsunami wave speed is given by v squared equaling gh, where g is acceleration of gravity and h is the depth of the ocean. For ultra-deep water, say with 5 kilometers depth, the tsunami wave speed is 763 kilometers per hour, almost the cruising speed of jumbo jets, which is about 800 kilometers per hour. In other words, tsunami waves travel rapidly through the ocean as fast as a commercial jet. As tsunamis enter shallower waters, it slows down. For example, at 100-meter water depth, the tsunami wave speed reduces to 113 kilometers per hour. However, the wave gets taller, the wavelength significantly gets shorter, and the period also gets shorter in order to conserve energy. Let's denote the height of tsunami waves by h. When a tsunami approaches the shoreline, the velocity decreases because the water depth decreases. Remember that energy is proportional to tsunami wave speed and tsunami wave height. In order to conserve energy, the amplitude increases as we approach the shoreline because of the tsunami wave speed. So, despite this striking characteristic, a tsunami in an open ocean passes undetected because its height is usually less than 1 meter, and the period ranges between 100 kilometers and 700 kilometers. However, upon entering shallower coastal waters, these destructive waves are slowed down because the water depth decreases, and the water begins to pile up to heights that occasionally exceed 30 meters. Let's look at the specific formulas of the heights of tsunami waves. Let's denote by uppercase H1 and uppercase H2 the heights of tsunami waves at water depths lowercase h1 and lowercase h2, respectively. We have the following relationship. Geological features such as reefs, bays, river entrances, and undersea formations may dissipate the energy of a tsunami. In some places, a tsunami may cause the sea to rise vertically only a few inches or feet. Flooding can extend inland by 300 meters or more. Tsunami waves can also be slowed down by human obstacles and change direction by refraction and diffraction. In other words, we can potentially reduce local damages resulting from the tsunami waves. Most tsunamis, about 80%, happen within the Pacific Ocean's Ring of Fire, a geologically active area where tectonic shifts make volcanoes and earthquakes common. Only about 10% of tsunamis happen in the Atlantic Ocean. Tsunamis are sometimes incorrectly called tidal waves. Tsunamis are not tidal waves. Tsunamis are not caused by the tides. Tides are caused by the gravitational force of the moon on the sea. Here is a summary of key differences between tsunami waves and tidal waves, also called wind waves. Wind waves influence the upper 100 meters. They have wavelengths of several tens to hundreds of meters. Wave height and wavelength are related to wind speed. Wave velocity reaches a maximum of several tens of kilometers per hour. Waves break in shallow water and expend all stored energy. With tsunami waves, they influence the entire water depth. They have wavelengths of several tens to hundreds of kilometers. The wave height and wavelength are unaffected by wave speed. The wave velocity maximum is several hundreds of kilometers per hour. Waves come ashore as a raised plateau of water that pours onto the land. Let's describe and illustrate some examples of tsunamis. The 2004 Indian Ocean tsunami occurred on December 26, 2004. This is the Sumatra earthquake, with a moment magnitude of 9.3. The ruptured fault areas were about 1,200 kilometers times 100 kilometers, with a slip up to 15 meters. Entire communities were erased, including buildings and people on a nearby island. The 2004 Indian Ocean tsunami could rank as the most devastating on record. More than 200,000 people lost their lives, many of them washed out to sea. The tsunami wave speed was 800 kilometers per hour. The tsunami increased in height as it approached the coast of Indonesia, Thailand, Sri Lanka, India, East Africa, and various islands. Low coast areas were inundated by as much as 20 or 30 meters of water in Indonesia and 12 meters in Sri Lanka. Cities and villages were completely demolished along hundreds of kilometers of the Indian Ocean coast. Many people were killed by the Indian Ocean tsunami because they went down to the beach to view the retreating ocean exposing the seafloor. A receding ocean may give people as much as 5 minutes warning to evacuate the area. Remember that a tsunami is a series of waves, and that the first wave may not be the most dangerous. The danger from a tsunami can last for several hours after the arrival of the first wave. A tsunami wave train may come as a series of surges that are 5 minutes to an hour apart. The cycle may be marked by a repeated retreat in advance of the ocean. Survivors of the Indian Ocean tsunami reported that the sea surged out as fast as powerfully as it came to shore. Many people were seen being swept out to sea when the ocean retreated. A tsunami surge may be small at one point of the shore and large at another point at short distances away. Do not assume that because there is minimal sign of a tsunami in one place, that it will be like that everywhere else. Tsunamis can travel up rivers and streams that lead to the ocean. Stay away from rivers and streams that lead to the ocean as you would stay away from the beach and ocean if there was a tsunami. To help you grasp what happened in Sumatra in 2004, let's look at photos of Banda Aceh a couple of months before the tsunami and the same region a couple of days after the tsunami. Here is a satellite image of the waterfront area of Banda Aceh province's capital city before the tsunami. Here is Banda Aceh, Indonesia on December 28, 2004, after the tsunami. Notice the destruction. The shorelines are nearly wiped out. Entire communities were erased, including buildings and people on a nearby island. Let's talk about the 2011 Japan tsunami. At 2:46 on April 11, 2011, a 9-magnitude earthquake occurred in Japan, 231 miles northeast of Tokyo. Ground shaking from the main shock, which lasted about 300 seconds, and the hundreds of aftershocks, many in the magnitude 6 and more range, damaged homes, buildings, essential facilities, nuclear facilities, and critical lifelines, for example, transportation infrastructure, over a wide area. This earthquake caused tsunamis because it offsets the ocean floor. The tsunami, which following within about 10 minutes changed Japan's coastlines, inundated land in urban areas, swept people and cars away, left tons of debris, created the potential for waterborne diseases. The explosion in the Fukushima Daiichi nuclear facility created a nightmare disaster scenario that included radiation release and possible nuclear meltdown. Now it's time for a quiz. When we return, we will go over the answers to the questions posed in this lecture. Now we're back. Let's review the questions and their answers. In our first question, The December 26, 2004 Sumatra earthquake, with a moment magnitude of 9.3, ruptured fault areas of about 1,200 kilometers times 100 kilometers, with a slip up to 15 meters. Entire communities were erased. Buildings and people on a nearby island also. How long does it take to get to Sri Lanka? The distance from Sumatra to Sri Lanka is about 1,600 kilometers, and the water depth in Sri Lanka is about 4 kilometers. The answer is as follows. Notice that the numerical model using observed source and high-definition bathymetry of the front propagation below confirms this result. In the next question, suppose that the height of tsunami wave is 0.6 meters at 4 kilometers water depth. Determine the height of the tsunami wave at 10 meters water depth. The answer is as follows. Remember, there is a large selection of iMode education lectures, which can further enhance your knowledge of earthquakes, volcanoes, climate, and energy. Thank you for listening to this iMode education lecture.